looking to have a deeper understanding of polynomials and what these can represent or be used for? If that's the case, welcome to Math Tutorials 82, where we master together the skills that will set you up for success. Polynomials are found in real life, in industry, and in an educational environment such as this one. They are used to characterize phenomena, processes, situations, etc. in our life that cannot be characterized using a simple linear 1-degree equation. So in order to make this a little bit more apparent, I came up with one scenario. So for instance, you would like to fill up your aquariums with water using a hose, and after the aquariums are filled up with water, you would like to place some decorations and goldfish within the aquariums. So I came up with 2 aquariums just so we're talking apples with apples. So this would be a rectangular aquarium with your castle, your little vegetation, and your goldfish, if you go with the rectangular route. And if you go with a spherical, well, you have also your decorations, your little vegetation, and your goldfish. So here your goldfish seem to be swimming and thriving in both situations. So whichever one you choose will be a good choice. So going back into our equation, so since you decide to go above and beyond, you mark each tank after just 1 minute has passed by to see where the level of the water is. So for the rectangular tank, which is the first one we'll start with, when you did this exercise, your rectangular tank had the following dimensions. So this is what you found. So your rectangular tank, which had a length of 20 inches, width of 20 inches, and a height of 14 inches, after 1 minute, it was at 2 inches in height from the base up to here. After 2 minutes, it was at 4. After 3 minutes, it was at 6. 4 minutes, 8. 5 minutes, 10. And 6 minutes, 12. So you decided to create an equation in order to show the fill rate of this aquarium. So this is what you got. So you got this nice linear, simple equation, which is y equals 800x, where x is the time in minutes, and y is the tank volume in inches cubed. So after 1 minute, the tank is filled up to 800 inches cubed, and after 6 minutes, it's at 4,800 inches cubed. And so you now know that approximately in 6 minutes, your tank will be ready to go, because of course you can't really fill it up to the brim because you need to put on the thermostat, the oxygenator, and all that good stuff inside there with all the decorations. So all that takes up volume, but that's another topic for another video, but just to give you an idea. So you now know that the fill rate is linear. It can be expressed with this equation. However, when you went to do the same thing with your spherical aquarium, you noticed something very different. You were expecting it to be exactly the same as your rectangular, but you notice that after 1 minute, because the volume here at the lower end of the tank was smaller, it actually got filled up to 3 inches. After another minute, it got all the way up to 5 inches, but it slowed down. So after 3 minutes, it went up to 6.5 inches. 4 minutes, it went up to 8 inches. And after 5 minutes, it went up to 10 inches. So this spherical tank has the same height as the rectangular. So it has 14 inches in height. So you're like, well, I'm thinking the rest will get filled up even faster because the volume up here is very similar to the one down here. So probably another minute, 2 minutes, it will be over the brim. So you try to create an equation for your aquarium, and you notice the following. It wasn't that simple. So you notice that it filled up faster at the beginning. Then as it got to the middle of the tank, it slowed down. But then when it got towards the upper end of the tank, it started to speed up again. So this isn't quite a linear expression like you had with the rectangular tank, where in the rectangular tank's case, you had a slope of 800. And so if you'd like to learn how to determine the slope of a line, I will link that video at the end of this one. So you notice you really can't use a first degree or monomial here in this case because it just won't make sense. So you decide to use Excel to try to create an equation that makes sense. And so you go with a second degree equation, which is a polynomial because it's already second degree because you have x squared and x. And the line doesn't make any sense here still. So you go up an additional degree. So you go up to a third degree equation to see if that will represent this line or this fill rate. And you're still not there. Like it's starting to look like it's no longer a line. It's like going somewhere, but it still isn't close. So you decide to go up to a fourth degree equation. And what you find is that as you go up, the function will start to look more similar to the actual behavior or fill rate of the spherical tank. But now the question is, how close is this equation to the reality of filling up this spherical tank with water? Well, I'll demonstrate that. Of all that. So we had x equals time in minutes to the time it will take to fill up the fish tank, and y we had volume, which we were measuring in inches cubed. And so the fourth degree equation that we got from Excel was the following. So what we can do here is replace our variables so that we can make this a little bit simpler. So we can say that a equals x, b equals x squared, c equals x cubed, d equals x to the fourth, or that d equals b squared, or d equals c times a. So we'll have 3 equations and 4 variables in this case. So we'll have 64.36 d minus 788.94 c plus 3,321.9 b minus 5,203.3 a plus 2,662.5. So this, in theory, should make things a little bit easier because now we have 3 equations, 4 variables, or before we had 1 equation, 1 variable. But, this is just to show that with algebra and with polynomials, you just have to work with, with what makes sense and how to make things easier. So in this case, it's just to show what's possible, what you can do. So, and also since we're testing out the actual function we got with Excel, I'm just going to do a rough sketch of the graph. So when x equals 0, that a and b and c and d are all 0. And so for 0, we have that y equals 2,662.5. So that's right here. However, this is an outlier because that is more than what our aquarium or spherical aquarium's volume. So this is kind of, I'm going to put it as a little red point so that you can see it a little bit better. So now for the other one. So at 1, it's 56.62. At 2, it's 261.74. At 3, it's 861.48. At 4, it's 983.7. At 5, it's 1,301. And at 6, we have 4,030.62. Since this is another outlier, I'm going to put it in red. So overall, this is what our function would look like that was given to us by Excel. So it says that if, to begin with, the aquarium is completely filled even over the brim with water. So we know that can't be true. And also it says that after 6 minutes, it's going to overflow, which is this one right here. And so right now, the only part of the equation that sort of kind of makes sense would be this part right here, which is between 1 minute to 5 minutes. But that's something that you always have to test out with all your polynomials or all your equations just to make sure that they make sense. So if you've made it this far, you get 3 gold stars. So what did we learn here? So polynomials of higher degrees can be used to represent nonlinear functions or situations in real life. The higher the degree of the polynomial equation, the more accurate the function is. And so hope this has been insightful. And if you'd like to know more, feel free to check out all my other videos. I'll link another video here at the end. And I guess I will see you in the next one.